My name is 𝘕𝘬𝘯𝘬. I'm a professor at 𝘎𝘬𝘯𝘧 University, and I'm talking about the fossil record. This is a subject that's dear to my heart. I've wanted to really focus on the paleontological patterns of the flood for most of my life, and this is sort of the beginning of my foray in that direction. The fossil record has played a pretty important role in creation theory for a very long time. You can go back to Tertullian in the 2nd century, and he was pointing out seashells on mountains and deducing that the flood, global flood, reached that point. So he's using fossils even nearly 2,000 years ago. The fossil record order was important to John Woodward in the late 17th century, created a flood theory. Actually, there were several theories of the flood and theories of the earth that were produced in that decade at the end of the 17th century. A bunch of flood models were generated, and they were almost all based upon, in large part, Woodward's completely, on the basis of fossils. The mixing of fossils that George Macready Price thought he saw in the fossil record at the beginning of the 20th century he came to deny the integrity of the geologic column, and thus argue, since the geologic column wasn't real, it was artificial, created by evolutionists, and therefore creation by default. Later, one of his students, Clark, sees associations. He in fact thinks he sees a real geologic column based upon fossils, and deduces that the organisms of the pre-flood world were living in different places, and the flood came up and buried them in succession. And so he tried to explain the order of fossils in the record in that fashion by arguing that the pre-flood world was heavily biozoned. Whitcomb and Morris, in their famous 1961 book, argued that preservation of fossils was so good that it argues for a global flood and argues for catastrophic transgression. Ironically, most of their evidences are actually from what we believe are post-flood fossils in the present. But nonetheless, again, the fossil record has played an important part in the development of models all along. A paper I participated in some years ago on the fossil horses, we argue for the diversification of organisms after the flood. So the fossils have always played a major role in creation theory, but they have not been studied systematically. And we have now, the secular world has produced what's known as the paleobiology database, or the paleo database, that is attempting to collect all of the information on all of the fossils of the world. It's sort of like a fossil record equivalent of the Wikipedia, where people can contribute their ideas and their definitions into this thing, and collectively, hopefully as a world, we can collect all the information. So the idea is to collect all the information on all the fossils all over the world, and that's only going to be possible if a whole bunch of people from all over the world put that information in. We're a long ways from that. The paleo database is only about 30 or 40 years old or something like that. But there's several million, I think it is now, specimens recorded in there. So we now have a database that is substantial enough to really work on global fossil record data. So this is an attempt to use the paleobiology database to apply it to creation theory. What I'm going to do in this particular talk is to use one particular measure of fossils, fossil record characteristic, and that's paleontological continuity. The idea here is I consider two particular discoveries of a particular fossil to show paleontological continuity if they're superimposed on top of one another and they're occurring on both sides of some boundary. So there's continuity between one and the next because they're found in the same area, right on top of one another, and there's no discontinuity between them. Discontinuity would be where one is found here, but the next one is found way over here, or way up at a different level. So paleontological continuity would mean two things are superimposed on one another, very close together. Discontinuity would be the opposite. They're not superimposed on one another, or they are found at a very distant location. And it turns out measures of paleontological continuity have played a part in the study of the fossil record as well. Paleontological continuity has been argued by Tertullian, for example, when he finds fossils of the present that are found, organisms of the present that are found as fossils in the same, they're marine organisms, but found in a place where they're not currently marine. That would suggest that the marine used to be up at the top of mountains. Stephen Jay Gould developed his punctuated equilibrium theory based upon paleontological continuity. That species stasis, species remain the same through time because there's paleontological continuity between occurrences of species. At the same time, it's also been used, continuity has been used to argue for change. So Steve Gould argued for stasis, no change. But if you have continuous fossils that show change, even though they're continuous, superimposed on one another at the same place, they're nonetheless changing in morphology, then it's used, for example, to argue that the horses have changed through time, which I participated in a paper where we argued for that. Discontinuity has also been used. Discontinuity is common in paleontology to argue for extinction. You've got paleontological continuity for an organism coming up to a particular level, and then at a particular level, it all of a sudden disappears. There's discontinuity above it, and that's used to argue for extinction. Mass extinction, if a whole bunch of organisms, in fact, all disappear, show paleontological discontinuity at the same level. It's also used, paleontological discontinuity is used to develop the geologic column, the biostratigraphic column. When you find a particular fossil in a particular level all around the world, but not found above or below it, anywhere above or below it, then it's used as a time marker. It's assumed that that fossil lived all at the same time, that organism lived all at the same time around the world, and therefore it's a different time unit than the units that do not have that fossil. And it's with paleontological discontinuity that we develop the biostratigraphic column. We also use discontinuity to argue for flood boundaries. When we have Steve Austin and I argued for the pre-flood flood boundary as a point where there's a change in fossils from the pre-flood world to the post-flood world, to the flood world. And then Marcus Ross is using a method we're going to expand upon here to argue that there's a change in flood sedimented fossils and post-flood. There's a discontinuity, there's a change. So we're going to do that same. So there's what I'm doing here with using a measure of paleontological continuity or discontinuity is not new. It's something that's done in paleontology quite commonly. What we're going to do here is look for a measure of paleontological continuity which is at the finest possible scale on a global level. I'm looking for global patterns. I'm looking for fossil record patterns across the entire globe. And so I'm looking specifically at the paleo database. Taxonomically, The finest scale we can get consistently in the paleobiology database is a species level. Most of the fossils are in fact identified down to species level. This is great. Most studies of the past have focused on genus level, even family level designations. What's nice about the paleobiology database is for the first time we're able to look at things on a global pattern at a species level. And that's probably the finest we'll ever get. So this is exciting. Stratigraphically, the finest vertical measure that is available on that database is a stage level. So we have stages, and we have series, and we have periods, and we have all sorts of different sized stratigraphic units. And the consistent stratigraphic unit used around the world at the smallest level is stage. And so most of the fossil record this is going to be good for. We're going to see that in the Precambrian, we're going to have to go to a larger stratigraphic unit than stage. But for all of what we'd be interested in the flood, we get down to stage level, which again is really good resolution. Geographically, by the way, in the conventional world, that's about 2 to 5 million years resolution. On a 500 million year scale, that gives you about 100 divisions in the stratigraphic column, which is really nice. We got about 111. Geographically, GPS units are very often given in the paleobiology database. And so I'm going to define arbitrarily I'm going to say 2 fossils are from the same location if they are within 2 degrees longitude and latitude, and both of each other, which again is very fine resolution. I'd love to have it as, two fossils are in the same rocks right above each other, but the best we can do in the paleobiology database is 2 degrees long lat. So our paleontological continuity measure is the number of local, that is within 2 degrees latitude and longitude, stage boundary straddling species. So that's the NLS-SS measure. So it's the number of organisms that are on both sides of a boundary within 2 degrees long lat of each other, and the boundary is a stage boundary. Do that at every stage boundary. So how do we do this? To collect the data, go into the paleontological database there. For each biostratigraphic zone, it would be stages for the most part. There's 100 stages. And then when we're getting into the Precambrian, we've got to go to series, and then we also are going to look at it at the erythem level. These are the finest divisions, and then larger divisions, and then the largest divisions. We're going to download from the PDF. What you can do with the paleo database is you can put in a query, and you can have it download all of the examples into a spreadsheet. So we're going to download from the paleobiology database every species that's in that stage. That's 115 files to start with. We're going to delete every report of a fossil report where the age error is greater than the length of the biostratigraphic zone, than the length of the stage. Then we delete all the reports ID'd only above the species level. So we're left only with species level. So now we have only species that are fine enough, that are known in fine enough detail to be potentially right above or below the boundary. And then at each boundary between 2 stages, combine the data. So we take all of the fossils from the stage below, combine them with all the fossils from the stage above for that boundary. That gives us 114 files. We delete all the species that are not found on both sides. So we dump the species from the one into the other, and any that weren't found on both sides, we get rid of those because we're only interested in the number that actually cross over the boundary. And we delete all the reports where the species on each side of the boundary are further than 2 degrees long lat away from each other. The number of species that remain in that file would be the number of species that are found on both sides of the boundary that are within 2 degrees long lat of each other. And that's the NLSS number for that boundary. A number of boundary straddling species. And here's the result. We have, starting at boundary number 1, going all the way up to boundary 114. These are the oldest, the very earliest boundary, which is between the Hadean and the Archean. Very youngest boundary, which is between the late Pleistocene and the Holocene. So again, they're just numbered from 1 to 114. Second column in each case gives our NLSS number. So going from the late Pleistocene to the Holocene, 5,412 species crossed over that boundary within 2 degrees long lat of each other. 10,200 go from the Preabonian to the Rupelian. None, 0, go from Cambrian 2 to Cambrian 3, and so on. That column is the total number that are in that combined file, and then the third is the NLSS number. So of the 5,412 that are found on either side of the boundary, 479 cross that boundary. 1,000 cross the boundary before that. And all the way over here, 0 cross the boundary out of 34 that are found in either one of the boundaries. The last column is just the percentage. 479 is 9% of 5,412. So I have both a NLSS number and an NLSS percentage for each of the entries. Okay, I can plot it. Here's the percent NLSS values, that last column. From the very oldest, the very first boundary, you can't see those little numbers. Those would be numbers 1 through 114 down there at the bottom. Of course, you can't see that. But then this number here is the percent from 0 to the maximum is almost 40%. You can see that the numbers are kind of wild throughout the fossil record. And again, this would be the old stuff here, young stuff here. Now that's percent values. Here are the actual data values as opposed to percentage, the number. And of course we have in excess of 10,000 crossing one of the borders. So here we have the raw data. Now this can be plotted against the biostratigraphic zone from 1 to 114, which is done here, or it can be done with the associated radiometric age. And so I show both of them. It doesn't change very much to replace the zone number with the actual radiometric number. Meaning for the most part that the stages are all about the same radiometric age length and doesn't change the pattern very much. Okay, so there's there's a blow up of the raw data for the 114 zones. Now I see when I look at this data, stare at it for a bunch of time, I saw 5 different zones here with different patterns or behavior of the data points. There's this zone here where we have extremely low values, most of them 0. Then we have another zone here where they've got low values but non-zero. We've got an intermediate zone value here, but also quite variable. and then one zone with very high but variable levels, and then this strange one in the middle, which has got very high values but not very much variability. I think that shows up qualitatively as distinct zones in the fossil record. So again, 0 to low NLSS values, low to medium, medium to high, very high, oscillating values here, and very high, consistently high values in the middle. The other thing when I look at, and this is one thing when I'm looking at data, even before I quantify it, I look for patterns that then I might test for to see if in fact they are there. This stuff strikes me as possibly periodic on a regular basis, maybe. So possible periodicity in especially the upper two. And that's something I'm going to look at, or will look at in the future. Now, in putting it in terms of conventional, if people are familiar with the biostratigraphics column, this is the Precambrian and Cambrian zone. Precambrian, Cambrian. This is the Ordovician through Mississippian up to the bottom of the coal seams we're familiar with. And this is the Carboniferous, the coal seam zone. This is the Mesozoic, the age of reptiles. And this is the Cenozoic. Actually fits very nicely with, even though those, I tried not to let myself be biased by what I already knew about the fossil record, but those 5 zones do seem to break into the erythem boundaries that we're familiar with. Okay, let's look at each of those in sequence a little more carefully. First of all, the Precambrian Cambrian NLSS zone. That was one that showed up as almost zeros all the way across, very small values. I'm stretching them a little bit so you can see the non-zero values a little better. There is something different about this zone that from all the others, which needs to be pointed out right away. These other zones are defined biostratigraphically. They are defined by fossils. These zones are not. There is a little bit on a couple of these, but these are for the most part based not upon fossils, but upon lithology. And so they're not defined the same way as these. And these are not stages either. They're larger biostratigraphic units. So these are different already from these things. So that might be part or all of the reason for the difference between what you see here and what we see in the later zones. So a question that has been floated around, battered around in creationism for quite some time is whether there are really fossils in the Precambrian. It was the contention of George Macready Price, who didn't believe there was a geologic column, that there were no fossils below a certain point, and it was certainly the position of Whitcomb and Morris that there are no fossils in the Precambrian. Of course, for all practical purposes, the first Precambrian fossils that are certain come in 1954 with the discovery of fossil bacteria in the Precambrian. And it's only really been since the publication of the Genesis flood that Precambrian fossils have come to be accepted. But this particular issue, you might say, well, look, you got zeros all across here. You got a lot of zeros, not just in the NLSS numbers, but also in the number of species that are found above or below the boundary. Maybe that means there are no fossils in there. Well, it's not exactly true, because if you look in the database, we took out the fossils that are not known at the that are known at only higher taxonomic levels than species, that are known at the genus level and so on. And that took out almost all of these, because most of the Precambrian fossils, they do exist, but they're not identified down to species level. They are bacteria, primarily bacteria, cyanobacteria, and so on, that we typically do not classify any finer than genus level. So it turns out that in making this as detailed as species, we've eliminated most of the data here. The other problem here is that because these are defined lithologically, they indicate a very large change in rock type from one level to another. And it may be that that's determined, that's really, if the species are being brought in with the sediment that they were associated with, they're probably not crossing boundaries, because they're from a completely different area. And so the fact that we're getting no continuity is perhaps an artifact of the way this material is deposited. And in fact, if you look at the data at genus level, which I've just begun to look at, and I need to look at it some more often than not, genera go through the multiple layers all the way through. So it's probable that we have to look at a higher taxonomic level to look at the detail here in this zone, in this region, the Precambrian in particular. So that's work in the future. I think I need to redo this at a higher taxonomic level. Do the whole column at a higher taxonomic level for comparison purposes. And at this point, there's not enough data to evaluate at a species level. Is there periodicity? I developed a metric, actually I modified a metric that Dave Raup produced to argue for the periodicity of mass extinction events. And I played with that a while, and I don't have very much data. Very difficult to quantify that small amount of data. The other problem we have here is that radiometric time is definitely not constant through here. Whereas up here and above, you've got radiometric time in each of the stages that's roughly equivalent. Sometimes here we have 100 times as much radiometric decay occurring in a stratigraphic unit down here as up above. And that has something to do with time. I don't know what that is yet, but that may be throwing us off too. I'm not sure how to deal with that. It's probable that since we've also got very different lithologies down here, we've probably got very different chemistries involved, and very much different depositional processes. All those things throw wrenches into the machine of determining periodicity. I think the periodicity needs restudy. We need to restudy it at a higher taxonomic level and look more carefully at lithology. At this point, that's all I can say about that zone. Now, the reason I really did this in the first place was to use this continuity measure to identify the flood, post-flood boundary. The idea is as follows. If we've got a stable population of organisms living through long periods of time, like let's say living through that pre-flood world period, 1600 years, or more recently, something that's been living in the Gulf of Mexico for the last few thousand years. If you've got a stable, unchanging environment, you would expect that fossils are being formed continuously underneath the living quarters of these organisms, and thus you would expect continuity paleontological continuity of the fossils underneath stable, unchanging environments. So I would expect that during the pre-flood period, there should be paleontological continuity that characterizes that entire period of time. And I would expect that sometime after the flood, we'd expect paleontological continuity there. But let's say we look at the day the flood began. That particular day, these little critters are living wherever they're living, in the water or on the land, and their whole world gets messed up. We have evidence that the early flood moved sediments a long ways. Lots of erosion occurred. So the little critters that were living here are being carried boom, a long ways away. I wouldn't expect the organisms in the earliest flood sediments to be buried in the same place that they lived. I would expect them to have been moved to some other location. So I would expect there should be a paleontological discontinuity at the flood, pre-flood boundary. Therefore, I would expect zeros in that third column for the pre-flood flood boundary. During the flood, if we have organisms that are picked up by the waters of the flood and carried around and deposited at various times and places, I would expect that there's good evidence that they're being carried as a group, and I would expect them to be the same organisms at the beginning of the flood as the end of the flood, and in many cases I would expect that they should be deposited in the same place. Now, as flood waters move things along, it might ching, 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 ching. It might move the fossils along, but at each successive interval, I would expect paleontological continuity to largely, at least a simple view of the flood, would be there would be continuity within the flood, before the flood, but a radical discontinuity at the beginning of the flood. Likewise, at the end of the flood, especially in, let's take terrestrial animals in particular, you got animals that are preserved on the ark that were deposited in the flood in various locations of the world. Now the only ones that are alive at the end of the flood are at the ark. They then disperse from the ark and go settle in some place around the world. What's the likelihood that they're going to settle in the same place that they got buried? If they were not buried all around the world, they were only buried in a certain place, I would expect the likelihood is basically zero. So I would expect also at the flood, post-flood boundary, there to be paleontological discontinuity. So I would expect continuity above, below, and in the flood, and discontinuity at the beginning and end of the flood. So back to this. What about the pre-flood flood boundary? I would expect that to be a zero, NLSS of zero. Problem is that we have a bunch of zeros. So where do we put it in here? That's the first thing that was somewhat disappointing in this process, is I've got a lot of zeros to choose from. Well, I guess the good side is it's probably one of those. Now here's the traditional location of the pre-flood flood boundary, is at the base of the Cambrian. Actually, if there's a place it's not, it's probably there. I guess that's one of the few places we don't have zero. Although Steve Austin and I argued for a cryogenian Ediacaran boundary, actually Ediacarantonian somewhere in this zone, and that really is in one of these zeros. So I'm inclined to think that this is where the flood, post-flood boundary is. But notice we have zeros above and zeros below. There are too many zeros to use this method to determine the pre-flood flood boundary. Although again, it does include the traditional pre-flood flood boundaries. What can we say if we do assume this is the boundary? Does that say anything about what was happening before the flood? Given that we have so many zeros before the flood, it may mean that there are multiple catastrophic events, like multiple floods or something like that, that occurred Again, I would expect if you got non-catastrophic conditions, I would expect continuity. But we don't have much in continuity here. There's a lot of zeros. It looks like discontinuity is going on. So what is going on? It's very possible that this actually refers then not to the pre-flood period, but to the creation week period. And that these are, and I have argued that many of these sediments were actually produced on day 3 of the creation week. It could be that we're looking at catastrophic depositional events during the creation week. We've got to come back and study this in the future. And again, I think we need to do it at a higher taxonomic level with finer detail in order to get at that particular problem. So now, on the other hand, there's interesting, what do we do with zeros after the beginning of the flood? And here, traditionally, if you're a paleontologist, you recognize this automatically. It is well known in the fossil record that the Upper Cambrian is very heavily biozoned in the fossil record. And that seems to be verified by these, by the zeros that we see here. So there's something interesting going on here at the above the traditional pre-flood flood boundary in the early flood rocks. This is, again, there are multiple zeros, hard to know what to do with those at this point. It's going to require further study. An earlier study I argued for a sequence of faunas that lived on the pre-flood, on the edge of the pre-flood continent and were buried in succession in the upper Precambrian and lowermost Cambrian. This would be below those zeros that we were just looking at. So there seems to be biozonation evidenced below the zeros. The zeros imply some sort of biozonation. So I think we're probably looking at strong biozonation in organisms at the beginning of the flood. That's going to have to be something we come back to and look at in the future. Going to the other end of things, what about the flood, post-flood boundary? Again, I would expect a zero. And we don't actually have a zero. So at the pre-flood flood boundary, we got too many zeros. At the post-flood flood boundary, we don't have a perfect zero. We have some that get very close to zero. That 2 degrees, by the way, would give us fossils that are within about 200 miles of each other. We have hundreds of species living in the post-flood time greater than, less than 200 miles away from where they were buried in the previous level. If we want to put the flood, post-flood boundary up high, we're going to have to say that something on the order of 1,000 species around the world actually are found on both sides of the flood, post-flood boundary. The absence of a zero would suggest that I can't be sure where it is, but I can be sure of a few things. It's not here. It is, and it's not at some of these very high, 600, 400, 200. There's only a few places where it could possibly be, and it cannot be at, in creationism, there have been people arguing for a very high boundary, which is right up here in this zone here. And there's no conceivable way that a Pleistocene boundary can be entertained for the end of the flood by this. But if it isn't there, where is it? And of course, we begin getting candidates at these locations. So let's look at it a little differently. So it's definitely not in the upper Cenozoic, but this data used all fossils, terrestrial fossils, marine fossils, everything was lumped together and not considered differently. So in the post-flood flood boundary, one thing that might sharpen that boundary is to look more specifically at marine fossils that are found on both sides of that boundary in the middle of continents. I would expect that that marine fossils are only going to be found in the middle of continents when the flood is there to dump them there. You're not going to find them, once the flood waters have receded, you're not going to find marine fossils in the middle of continents. So if we restrict our consideration to marine organisms rather than terrestrial organisms, because if you find terrestrial organisms above and below, maybe that's ambiguous, but marine in the middle of the continent, not so. So I would expect the NLSS to be 0 at the pre-flood flood boundary and the post-flood flood boundary, and at above, except for this one issue. Something a little funny about the fossil record, about the history of the Earth. After the flood, there seems to have been an ice advance. Continental ice built up after the flood and pulled up a whole bunch of water out of the oceans of the Earth. More than 200 meters of water was taken off of the oceans of the Earth and put onto the continents. Now a bunch of that melted and brought the ocean levels back up again. But even today, there's something like 60 to 90 meters below the level they would be if we melted all the ice on the planet. So immediately after the flood, even when all the waters were off the continents and at their lowest level, they were 90 meters higher than they are now. So once the glaciers pulled the water out and then melted to bring it back to what it is today, it leaves on the edges of continents, the shoulders of the continents, 90 meters of marine sediments that existed in the post-flood time before the glaciers formed. And so we would expect marine fossils in post-flood times to be on those shoulders of the continents that are now exposed on the continents. If they're less than 90 meters above sea level, they're along the coastal margins, they're in the coastal sediments, various things, easy to identify these things. Thus, you wouldn't expect marine fossils interior of those after the flood, but you would expect marine fossils on those shoulders. And in fact, you might expect continuity in those marine fossils on the shoulders, even in just before, maybe at the very end of the flood, because marine organisms might have been establishing themselves, begun establishing themselves on the edges of continents even before the floodwaters had fully receded. So you might expect marine organisms to show continuity across the post-flood boundary on the shoulders, but you should expect discontinuity, complete discontinuity, in the middle of the continents. So let's look at that. So we got for our purposes here, I'm just going to look at North America, and that's all I did for this project, and the next project is going to look worldwide. I've looked generally at the worldwide picture, and it looks the same as it does on North America, with one exception I'll get to. But here is a shot of the United States, the familiar portion of the eastern United States. These are the coastal plain sediments. So these are all sediments that are less than 90 meters above present sea level. This would have been the shoreline of the ocean at the end of the flood. That's, I mean, the end of the flood, not when the waters are high, but when you melt all the ice on Greenland and Antarctica, this is the shoreline we'd expect. That would be, if you want to invest in land, the melting of all the ice, you want to invest in beachfront property, that's where it is, right there. That's the beachfront property for the melting of all the glaciers of the Earth. About halfway down Georgia, about halfway along the east-west length of the eastern states. All of Florida going to be completely covered with water. But here we would expect marine sediments after the flood on what is now land, but we wouldn't expect marine creatures anywhere in between the coastal sediments. The West has very, very narrow coastal sediments. Here is the Pleistocene-Holocene boundary, the place where some people want to put the post-flood boundary. Notice all these dots represent the NLSS species that are crossing boundaries at the Pleistocene-Holocene boundary. They are all in the coastal plain sediments, all of them. There are none of them in the middle of the continent. So this is after the end of the flood, not at the end of the flood. We go back to the Upper Cretaceous, where some people have argued that the boundary is just above the Upper Cretaceous. We have marine fossils over the entire continent. That's clearly still flood. So as we move up somewhere between the Upper Cretaceous and the Pleistocene, you would expect all of these things in the middle here to disappear and be restricted only to the coastal sediments. And here's the boundary one above the Upper Cretaceous. We're losing most of this individuals in the middle. Got a few more in the next boundary. They reduce in the next boundary after that. They're almost gone in this boundary, and the ones that remain are on the shoreline of they're defining this, the shoulder sediments, which suggests that we are in that post-flood period. And then after that, all the boundaries above that are entirely restricted to the coastal sediments. These are the 100 to 112 and 113, 114, that's all of them. So backing up, we'd say this is all post-flood. So it's probably between 92 and 93 that we have the post-flood boundary. I think that's pretty strong evidence. I'm going to work on just the marine or sediments across the entire world, show that this is in fact the pattern everywhere, except in one place. One place that is where we find marine sediments in the middle of continents, the only place I can see is actually through this chain of mountains from the Himalayas all the way through the Alps. This is where you've got marine sediments in the middle of the continent. This showed up on some old, so John Woodmarappy, 1983, he was showing index fossils. He's plotting index fossils. And you can see in his world plot of index fossils in the tertiary, the Cenozoic, he's got all the fossils restricted to the edges of continents in the coastal plain sediments, except for these guys running right through the middle here. In contrast, these are the mammals in the same zone. So he didn't notice, he didn't make note of this, but it's shown in the distribution of index fossils that for the most part, the tertiary fossils, marine fossils, are restricted to this coastal sediments, with that exception through the Alps and Himalayan mountains. It's also consistent with a report by Tim Clary. He argues for a boundary very high because, not because he finds them anywhere else, but because he's got marine limestones through here. So just based on marine limestones, he gets the same pattern. I think that the real reason is for this is that this is actually marking a shoulder of two continents. One continent was the south, one continent to the north, what is now Asia to the north, and Africa and attached pieces to the south. They each had a shoulder of marine sediments on them at the end of this flood, and that after the flood, these two things crash together and produce the mountains that we have today in that region. That's going to require going back and looking at the geology of this, but I'm pretty sure I'm going to find that the geology is consistent with the idea these are actually not mountainous at the time they were formed, and that they are coastal plain sediments on both sides that got crunched up and smashed up to a high elevation in the mountains after the flood. So that is what I expect about the flood, post-flood boundary, future research as these other things were. What about periodicity? It's tried various periods. There's a mild support of it when you quantify it. But we have a problem again with the time. Geologic time is not constant here. Radiometric time is not constant. I suspect real time is not constant as well. So I don't know. I don't have a good starting point, and I need a good age indicator through here to test for real periodicity. It's possible there really is periodicity in this data. It's going to need some more rethinking in order to really test that for sure. But one thing that is true about this zone is it does have this high variability, these pulses of continuity and discontinuity, continuity and discontinuity. 4 rises are actually increasing the NLSS values by more than 100%. 5 of the drops are decreasing it, are more than a 50% drop in diverse NLSS values. These are pretty rapid and substantial changes in NLSS values. Couple possibilities I've thought of here. Could be that we've got catastrophism, post-flood catastrophism that's producing these. It's also possible that there are periods that there's a non-constant diversification of organisms. This is something I've been playing with for other reasons. And so what these things mean at this point, I'm not sure, but it's something worth looking into. That having been said, I've looked at the beginning here and the end, what I think is post-flood, what I think is pre-flood. What about what we see in flood sediments? This again divides into at least 3 different zones. A low NLSS value set of values here, medium NLSS values here, and then a high value in the middle. I think what's going on here is that these lower values are low because they're only measuring marine organisms, and that these are higher values over here because we have both marine and terrestrial organisms being buried. So we basically doubled the diversity of organisms. And so what I think we're seeing here is the initial waters of the flood is entirely a marine phenomenon. This has been suggested by creationists for a long time, that marine organisms are only involved in the early flood deposition, and then the flood waters came onto the land and picked off the terrestrial organisms only in the second half of the flood, at least second half of the biostratigraphic column. In between, this the high NLSS values here are mostly from the floating forest that I have suggested. So it looks like to me what's going on is that the floating forest is not being destroyed very much in the early flood deposition. It's floating in open ocean and hasn't contacted the land where it's going to be ripped up, but that it hits land at this point at the same time that the floodwaters begin to transgress on the land. And it destroys the floating forest and deposits it just at the point that the floodwaters are beginning to transgress the land. So we have, that suggests that in the Carbo-Permian period, Permo-Triassic period, is when the flood actually moves onto the land and begins taking out the terrestrial organisms. And so I think we have, for the first time, an actual quantifiable way of dividing the flood sediments into marine, wholly marine deposition, and then terrestrial. And again, this can be confirmed. Future studies, I'll look to quantify that hypothesis. Again, as in the case of the post-flood, we have a lot of up-down motion on the NLSS. 11 rises are greater than 100% during flood sediments, 11 drops greater than 50%. Could that be biozonation during the flood? I'm inclined to think it was. Could it also be different flood processes going on? Again, something for future research. But that second question brings up another question. What do these have to do? What does this pattern have to do with other things we're quite familiar with already in the fossil record? For example, here we have the record of the mass extinctions. Mass extinctions would be where we have many organisms disappearing from the fossil record at the same time. The largest mass extinction, the Permo-Triassic mass extinction, is labeled as 1, and then they're labeled, they're given numbers. It's not entirely quantitative, but they're ranked according to their strength. So the highest, the 12, is the weakest of the mass extinctions, and so on. One thing that surprised me, given that a mass extinction is paleontological discontinuity, I would expect, I got it here, I would expect that a mass extinction should show a 0 or a near 0 in the NLSS data, and it sure does work there, but it doesn't work anywhere else. The mass extinction data, interestingly enough, yes, the biggest mass extinction corresponds to one of the biggest drops, but other than that, number 2 doesn't. It's not a number 2 on this. It's really interesting. The mass extinction data is not in sync with the NLSS data, which I find very intriguing. I also tested this against the biostratigraphic column itself. So we have the erythems, Cenozoic, Mesozoic, Paleozoic, that the erythems fit the NLSS data to some extent. In other words, more specifically, the Cenozoic, that 5th zone, the Mesozoic, that 4th zone. Paleozoic is everything else. So roughly the major divisions, the erythem divisions, fit the NLSS data. But the famous Cambrian, Ordovician, Silurian, the system data here doesn't correspond very much at all to what's going on. So it appears that the biostratigraphic column was not built on paleontological discontinuity data, which is very interesting. Stage data, no correlation whatsoever. This one really surprised me. I thought the index fossils, the stage boundaries were going to show up here. But in fact, they do not. And so that suggests the stage boundaries have been based on something other than global, even though they're supposed to be global biostratigraphic zones. They are not based upon global paleontological continuity. And that's intriguing, quite intriguing. Exactly what that means in the long run, I'm not entirely sure. But even though the biostratigraphic column is real, it's not based upon the paleontological discontinuity that I'm measuring. And we've got megasequences. We've got evidences in the fossil record of increasing, actually decreasing energy of flood generated rocks. So we go with high energy producing conglomerates to lower energy, which produces sand, represented in yellow, to lower energy, which represents shale, which is in gray, to very low energy where limestones are being deposited. So that's the first megasequence, the Salk megasequence. Then the next megasequence, the third, the fourth, the fifth. You got the 5 megasequences in the well-defined finding upward megasequences in the fossil record that we as creationists have gotten excited about. No relationship whatsoever to paleontological continuity measure. None at all. Very, very interesting. In fact, not only is the megasequence data not related to NLSS data, but the megasequence data are also not correlated at all with the system boundaries, the stage boundaries, or the extinctions, mass extinctions. None of the paleontological patterns of the record are related to the lithological patterns of the later. The best we know, the best I can determine about the megasequences is they're representing energy, levels of energy in the flood. High energy to low energy, high energy to low energy, high energy to low energy. So they're pulses in energy of deposition. And that may be all they are. But those pulses have nothing to do with the critters that are being deposited, have nothing to do with the biostratigraphic sequence that has been developed from, again, the organisms in the rocks. So all this is extremely interesting to me. Probably created 100 times more questions than I had to start with. But I'm very excited about what is going on here for several reasons. One, it indicates we really have enough data in the paleobiology database to pull out substantive information, something that can help us look at global patterns. We've just never been able to look at global patterns before. And we can do that for fossils in this way. And I'm looking forward to working, continuing this work, looking at other, of course, higher level taxonomic levels here in the Precambrian, looking at possible periodicity, looking at causes marine versus terrestrial, as to whether that we're looking at 2 phases of the flood there, verifying that this is in fact the floating forest phenomenon, because if that's true, then I've got this picture in my mind of the floating forest floating over to the edge of the continent and beginning to be torn apart as the waters are moving out of the continent. For the first time in my life, I've got something of a picture of what happened during the flood, and it's the beginning of, I think, the kind of research we can do in creationism we've never been able to do before. So a few things that we can deduce from this. First of all, the Precambrian really is fossiliferous, and creationists have got to stop arguing otherwise. I still see arguments along that line from time to time. Testing marine versus land, we should be able to determine whether we've got 2 different zones in the flood. It's the first time we've been able to divide the flood sediments, if that's the case. I think we've got a definitive way to define the upper flood, post-flood boundary by marine sediments, marine fossils exclusively on the shoulders versus the center of continents. And that should put to rest, I hope, put an end to the discussion so we can get on to do some real research and determine, if we don't know what rocks are flood rocks and what are not, it's really hard to do research on these things. So it'd be nice to put an end to that. And put to death the upper Cenozoic flood boundary and probably settle on that Cambrian Paleogene boundary approximately. I think there's evidence here of biozonation and catastrophe in both flood and post-flood times. And I think we can get at a lot of that information by looking in more detail at this data. That's exciting to me. An interesting biostratigraphic hierarchy, which has always been intriguing to me, what in the world it means. The fact that we've got the stages and the series and that are independent of what's going on paleontologically on a global level came as a surprise to me initially. But the more I thought about it, the more I thought, well, wow, that's kind of interesting. The biostratigraphic hierarchy might not mean very much as we've put an emphasis on before. And so the mass extinction data, intriguing. What is there should be a relationship between mass extinctions and NLSS data, but so far I don't see it, and I'm intrigued to know what's going on there. I think that's going to give us some insight into things we haven't thought about before. I think all of this is hyper exciting. I feel like I'm just at the beginning, like you're in my cave research, and that moment you walk into the cave and the whole world changes. So now you're no longer in that world out there. You're now in the world of the cave. It takes a while for your eyes to get adjusted. This is a completely different way of looking at the fossil record than we've been able to do before. I think it's surprising us. It's surprising me on a number of different levels. And I think what it is I'm still getting my eyes adjusted to this. I'm looking forward to continuing this research on so many different levels. I'm going to need a lot of help, actually, in order to get this done in the next century. But I, for the first time, get the feeling we're looking into the processes, getting a chance to look into the processes of the flood. Not only to look at the critters, which I've always been interested in doing, but to actually get much more detail in what's going on in the flood.